We will talk about type definitions, right? Uh, Type definitions is a way to let the programmer define his own data types, much like integer, char, like that. For instance, here we have declared a simple uchar underscore t as a data type. It's nothing but an unsigned char. It's just alternate way of defining unsigned char. So when you write your programs, especially in the corporate world, you always use your own definitions. And it's very easy to port your code to different uh, platforms. And here I declared char underscore t, which defines a char as a it's an extension of char. And most of these definitions, it's recommended that you always use a postfix of underscore t that says that we are using a type def. All right, and you're not altering the built-in types, okay, the default types. You are just creating extension, and most of the products that people develop, once they define, they'll only use the new data types. Okay, for instance, if you there is a file called user include. Okay, one second, let me load it down. Okay, standard int.h. If you see this file, line number 37, you have they have defined, see here, they defined signed char as int 8 underscore t. 8 is to portray that it's a 8-bit. All right, and here short int as 16-bit, and they defined it as int 16 underscore t. So just to let people know that it's a 16-bit, and here int is 32-bit. So when you develop products, you usually use these definitions. All right, this is what I have included in the PowerPoint. All right, the same as what you have done, and we have seen this, right? And just to show you, here I have declared typedef int int underscore t as a new data type. This is a new data type, okay, but I'm only defining it as a new data type. I'm not allocating any memory to it, okay. And then I can go ahead and use it the way we were doing it before. For instance, int underscore t space x. Here we are now declaring a variable of type int underscore t. All right. We'll come back to this slide little later. I'll show you some examples. Okay. Normally, the data types will be stored in a .h extension. Okay. Here I've used header.file. Okay. You can rename it to any file that you want, but it should have a .h extension. All right. Here I've defined a new data types, C char, unsigned char as u char underscore t. I can define a new data type into, right? Or you can use the existing data types that are defined in the user include. You can do that too. Anyway, the so the data types are defined in here, and if you take typedef, let me check if okay, here the way you include that file is include you include that file header.h. See the distinction between the angle brackets and a double quote. This is very important to distinguish between the header files that you declare for yourself, for your program, and the header files that the system provides for you. So whenever the files that you are using from the system, you always include them with angle brackets. And whenever you including files that you defined, you developed, you are using for your product, you always use the double quotes and the path. Of course, here I don't put the path because this program is running in the same directory or folder as the header.h file. So you don't include path in here. Okay, let me write here. Make sure your header.h file and the program are in the same folder or provide the path. Okay, and like I said here, user defined header file should be within double quotes. Okay, let's pretend we just change it to angle brackets. What really happens, right? Let's say you by mistake you put angle brackets and you include that in your program. I'm going to save it. GCC typedef, right? You see here, fatal error, header.h file, no such file or directory. It's unable to find that in the system. So you go ahead and change it. Oops. All right. And the data types you have provided in the header.h file, you can use them. See here, now henceforth, I will use my own definitions in my program. Okay. But if you feel like you want to use the system provided data types, you can still go ahead and say unsigned char z equal to x. This is fine too. But normally we don't use it. We don't mix and match these definitions with the primitive data types that the language provides. We usually leave it the way we define our data types. Okay, so let me compile this. Yeah, there's no issues. So that is the way to define the header files and the data types. Okay, oops, sorry. And most of the most of time in the corporate world or in any product development field, you always put all your definitions in here and you distribute this file to you other programmers and other team members because they want to use the same data type that you are using in the product. This usually comes from the team, from the architecture team, or from uh, the product, the core team. They maintain this across the life cycle of the product.